In this video, we'll look at two more examples regarding how to apply trigonometry to solve problems in plane geometry. Example 1. This is a past AMC 12 question. The problem says this. We have an equilateral triangle ABC, let's say side length is 1, and we extend BA to A prime so that AA prime is 3. Similarly, we extend AC to C prime, and the length of CC prime is 3 times of AC, and we extend CB to B prime. The length of BB prime is 3. Okay, so obviously the new triangle. Now we connect 3 points A prime, C prime, B prime. Obviously, this new triangle, this big one, is also equilateral triangle. Now, what will you find is the ratio between the area of the big one, A prime, B prime, C prime, and the area of the middle one, ABC. Alright, solution. Because both of them are equilateral triangles, they are similar, therefore the ratio between their areas is just the square of the ratio between their side lengths. We have the triangle A prime, B prime, C prime is similar to triangle ABC. This one just means similar. And then this implies if I put the side length of this is x and x, then we get the ratio between the areas is just equals the ratio, the square of their the ratio of their side lengths, which is x squared. Accordingly, in order to find the ratio, we just need to find the square of the side lengths of this big equilateral triangle. If we look at here the setup, you see, here we have, say if I look at triangle A prime, B prime, B, I have this is 120, this is x, this 3, and this 4. Then obviously, the most convenient way to find x squared is to apply the law of cosine. Okay. Let's apply. So by law of cosine. So then we apply the law of cosine to this triangle. We have this triangle. Here is this A prime, B prime, and B. This is 120. Here 4, here 3, and this is x. So we apply the law of cosine. We have x squared equals 4 squared plus 3 squared and minus 2 times 4 times 3 times cosine 120. Okay, so we know cosine 120 is negative 1/2. This one equals negative 1/2. Then we derive this. This one is equivalent to 16 plus 9 and plus 12. Okay, so then we just get equals 37. Therefore, the ratio between the areas equals 37. The second example is a past problem from math computation of UK. The problem says we have A, B, C, D. There are 4 consecutive vertices of a regular n-sided polygon. If we have this relation between the side lengths, 1 over AB equals 1 over AC, AC is diagonal, and plus 1 over AD, AD is also diagonal. Now, if this holds, what is the n, or what is the number of sides? Okay, so here basically what we need to do is we need to solve this equation. A natural strategy is, because here we just have AB, AC, AD, a natural strategy is to find a nice way to express AB, AC, and AD so that we can have an equation that is relatively easy to solve. Okay, here what we will do is let's put this because it's a regular polygon, right? So let's put it in a circle with radius 1. In other words, this regular polygon is inscribed in the circle of radius 1. Then I introduce a variable, which is this angle is, let's say, theta. So my goal is I want to express AB, AC, AD in terms of theta. So let's see how should do that. If this is angle theta, this is also angle theta because this regular polygon, all the sides are the same. And then if I look at the center angle, this is the center angle AOB, this is 2 theta. That's because we know within a circle, the center angle equals the twice of the corresponding in-square angle. So this is an in-square angle. This is a center angle, it's twice. Alright, so if I connect OC, similarly, this is also 2 theta and this is 2 theta. Now let's see how we express AB. Let's look at the triangle AOB. This is also 1, this is also 1, right? So this is an isosceles triangle. Let me draw the side, the height from O to AB, right? And it bisects the angle. So this is theta and this is theta. Therefore, if this is 1, by the definition of sine, we get this is right triangle. So we get this one is sine theta, right? So this is also sine theta, Okay. Therefore, what I get is AB. So we just derive the AB equals twice of sine theta. Similarly, if you want to find AC, we just look at the triangle AOC, right? So this is also an isosceles triangle with 1, 1 and 2 theta. So we get AC, we can derive AC equal twice of sine 2 theta. And then if you want to find AD, we just look at triangle AOD, this is 6 theta, and apply the same approach, we get this one equals twice of sine 3 theta. Therefore, this equation is reduced to equation that only involves the angle theta. So from here we derive, we can cancel 2 on both sides, so we get this 1 over sine theta equals 1 over sine 2 theta plus 1 over sine 3 theta. Okay, it boils down to solve this trigonometric equation. Now, as we said before, if you have a trigonometric equation, a general approach is to use those trigonometric identities to simplify the equation. Say we can factorize and so that we'll have some kind of cancellation to simplify the equation. Okay, so for this one, how should we apply that approach? What we do is we're going to move this one to the left-hand side. Alright, so this is equivalent to 1 over sine theta minus 1 over sine 3 theta equals 1 over sine 2 theta. Now let's combine this into 1. We will get is sine theta times sine 3 theta. And sine 3 theta minus sine theta equals 1 over sine 2 theta. Alright, now here we have a difference between 2 sine functions, sine 3 theta minus sine theta. And let's apply the difference to product formula, or say sum to product formula. Okay, that's what we call. So by this we know from the sum to product formula, we have sine 3 theta minus sine theta. This one equals is 1/2 sine theta times cosine 2 theta. Okay. Twice, but 1/2 is twice. Go twice sine theta and cosine 2 theta. Okay, so let's put this back to. Let's put this one back to here. Okay. And this leads to, we have twice sine theta cosine 2 theta divided by sine theta sine 3 theta equals 1 over sine 2 theta. Alright, now you see we have a cancellation. So that's what we want to see, right? I apply those trigonometric identities and I want to get something that can be nicely cancelled. So here I can cancel sine theta and sine theta because theta is not 0. Okay, now from here sine that's not 0. Okay, so from here we derive sine 3 theta equals twice sine 2 theta and times cosine 2 theta. And then we apply the double angle formula. 2 sine 2 theta times cosine 2 theta is sine 4 theta. Right, so we apply this. This one equals sine 4 theta. Alright, now what we get is sine 3 theta eventually. So the point is, we start from this equation, right, that involves one side and one diagonal and one diagonal. Then we introduce the variable theta. We express those things in terms of sine function of theta, and then we get this trigonometric equation after using trigonometric identities. Eventually, this one is reduced to what we have here: sine 3 theta equals sine 4 theta. Alright, now let's see what is the range of theta. Obviously, my theta it should be bigger than 0, right? And it's clearly less than pi over 2. Therefore, in order for sine 3 theta equals sine 4 theta, there's only one possible scenario. That is, so from here we get, the two are the same, we get, has to be 4 theta equals pi minus 3 theta. And this gives us theta equals pi over 7. So if theta equals pi over 7, and this means you get theta equals pi over 7, and this just get here, we'll just get 2 theta equals 2 pi over 7. 2 pi over 7. And this tells us so the side angle, so for each center angle corresponding to the side is 2 pi over 7, and this tells us the n equals 7. So it's a 7-sided polygon.